Imagine standing beneath a night sky that has always spoken, not in words, but in the quiet rhythm of discovery. Every supernova, every comet, every distant flare has told us something about where we came from. Yet, in late 2025, that cosmic conversation faltered. The data stream slowed, the updates vanished, and the world's most powerful observatories grew strangely quiet. The silence began with a dot, a single faint smear of light crossing Mars's orbit. Astronomers called it 3I Atlas, the third confirmed interstellar object ever recorded. Unlike the dazzling fanfare surrounding Oumuamua 2017 or 2I Borisov 2019, this arrival came with an eerie calm. No flood of images, no collaborative papers, just a press statement or two, and then nothing. To the public, it looked like a bureaucratic delay. To scientists, it felt like a blackout. Telescopes that usually released their findings within hours went days without comment. NASA's social channels, normally eager to showcase every cometary highlight, posted recycled frames from months prior. ESA released one overexposed image, barely distinguishable from background noise. China, the UAE, even India, nations with assets capable of observation, issued no statement at all. For the first time in modern astronomy, silence had become data. In scientific culture, silence means caution. It means verification, peer review, careful checking. But this silence felt different. It had a pattern, synchronized, intentional, almost rehearsed. What kind of observation could make 5 rival agencies act in unison? Why would organizations competing for prestige suddenly stop talking at the same time? Some said it was coincidence. Others whispered about embargoes, temporary pauses while data underwent deeper scrutiny. But a few began to suspect the unimaginable, that silence itself might be a signal, not from the cosmos, but from us. A collective decision to withhold something until the world was ready to hear it. For centuries, astronomy has been humanity's most open science. Images, coordinates, spectra, all shared freely across borders. When Oumuamua arrived, telescopes from Hawaii to Chile to Spain traded data almost in real time. When Borisov streaked through in 2019, even amateur astronomers joined the chase. But with 3I Atlas, collaboration collapsed into opacity. It began to feel as though the sky itself had entered witness protection. This story is not about proving conspiracy or alien intent. It's about exploring what silence means, scientifically, psychologically, and existentially. When our instruments capture something we cannot immediately explain, because the universe does not stop speaking. It is we who sometimes choose not to listen. And so begins the story of 3I Atlas, the visitor that turned the world's telescopes inward, forcing us to confront not just what we might find out there, but what we're afraid to admit down here. It appeared without warning, a blurry, asymmetrical patch of light released quietly by the European Space Agency. No grand announcement, no press conference, just a faint caption. Object 3I Atlas, observed near Mars orbit. Distance estimated 29 million kilometers. At first glance, it looked like an imaging error, the sort of smudge that happens when a sensor vibrates or a cosmic ray strikes the detector. But then, the metadata revealed something curious. The image came not from a deep space telescope, but from the Trace Gas Orbiter, a spacecraft designed to study methane on Mars, not celestial wanderers in deep space. The question practically screamed from the screen. Why was an orbiter built to study Martian air looking at an interstellar object at all? To anyone familiar with space imaging, the technical problem was obvious. Instruments like the orbiter's CASIS camera are calibrated for bright, near targets, the rust-red terrain of Mars, the thin shimmer of its atmosphere. They are not built to chase a faint, fast-moving comet tens of millions of kilometers away. Capturing 3I Atlas with such equipment is like trying to photograph a firefly from across an ocean, through a fog. And yet somehow they did. The image itself is haunting in its simplicity. No tail, no coma, no radiant plume, just a diffuse brightness, suspended in black. Astronomers who analyzed the frame noted something strange about its structure. The light distribution was too uniform. Natural comets tend to show gradients, asymmetries, jets of gas escaping unevenly. This was smooth, featureless, almost deliberate. Of course, there are mundane explanations. Long exposure times blur details. Dust near the lens can create halos. When data is stacked and cleaned, the algorithms can flatten structure. But even accounting for all that, the image remained wrong. One astrophysicist, speaking anonymously to a European journal, described it as a detection at the threshold of possibility. Another said, "It behaves optically like something that doesn't want to be seen." That phrase lingered. When we observe the universe, we expect resistance, light distorted by distance, signals lost in noise, but not intentional invisibility. It's not a concept science is comfortable with. And yet, there it was, a ghostly dot, whispering from the void, defying the instruments that tried to define it. ESA's official line was careful. The image showed a low-confidence detection consistent with a faint coma. In scientific language, that means we're not sure what we're seeing, but it might be what we think it is. Still, for many researchers, the phrasing raised more questions than it answered. Why was the detection even attempted? Why publish one image and nothing else? And most crucially, if this was the only viable capture, why not invite follow-up observations from other agencies immediately? Silence followed instead. To the data community, the ESA upload looked like a placeholder, something meant to satisfy internal protocol, not public curiosity. But some noticed another anomaly. The timestamp of the image file did not match the observation window disclosed in ESA's release. A gap of 17 hours existed between when the image was supposedly taken and when it was logged. That may be trivial, or it may be the first hint that multiple versions existed, only one of which saw daylight. These small inconsistencies matter because in science, uncertainty breeds imagination. The less we know, the more our minds fill the void. Was it a simple timing error, a cautious delay for data verification, or something selectively edited before reaching the public archives? The truth may be none of these, but the sequence felt rehearsed, a dance between transparency and omission, familiar to anyone who has watched information managed by institutions under pressure. Because sometimes, what isn't shown tells a clearer story than what is. If you overlay the ESA image on trajectory maps of 3I ATLS, you find that the capture angle was unusually oblique, almost 90 degrees off the expected observational vector. That means the camera was pointed not at the object's predicted location, but slightly behind it, as if tracking a wake rather than a body. It's a small thing, but in astrodynamics, small things matter. Either the prediction was wrong, or someone suspected that what they were observing moved differently than expected. ESA never clarified the discrepancy. They didn't have to. Within the culture of space science, ambiguity buys time. Time to double-check, time to coordinate, time to decide what story the data should tell. And that's how the silence began to feel like choreography. Perhaps nothing extraordinary happened. Perhaps 3I ATLS is exactly what its name suggests. A dim, distant comet on a hyperbolic escape. But history has taught us that silence has gravity. It bends truth around it, distorts perception, and pulls speculation into its orbit until the simplest facts feel uncanny. When a picture refuses to explain itself, we start looking for meaning in the noise. And maybe that's exactly where the next part of this story begins. In science, silence is rarely random. It follows patterns, shaped by protocol, politics, and fear. And in late 2025, that pattern became visible from orbit. First came ESA's minimal release. Then NASA's communications slowed, their tone softening into safe, procedural language. No threat to Earth, under continued observation, consistent with natural origins. Those phrases are not lies, but they are buffers. Words designed to hold space until certainty arrives. Except certainty never did. Over the following weeks, China's National Space Administration published nothing. The UAE's Hope orbiter, perfectly positioned to view the same object from Mars's orbit, did not attempt a single observation. Russia, whose telescopes once broadcast every meteor streak across Siberia, posted nothing. And India's ISRO, eager for scientific prestige, quietly sidestepped the topic. A strange global stillness emerged, as though the world's observatories had inhaled and forgotten to exhale. For those inside the astrophysics community, the timing was impossible to ignore. Every major space agency had overlapping windows of visibility between October 2nd and 6th, when 3I Atlas made its closest pass relative to Mars's orbit. Under normal conditions, that alignment would trigger a flood of cooperative data, shared light curves, joint press briefings. Instead, what followed were non-updates, statements repeating old information, issued in multiple languages, almost word for word. That's not coincidence. That's choreography. There are three possibilities when communication stops moving. The first is technical: equipment failure, calibration delays, data corruption. The second is scientific. The evidence is unclear and caution prevails. The third is political. Information has entered a space where meaning becomes dangerous. The third possibility is uncomfortable because it implies coordination, and coordination implies motive. But before imagination races too far ahead, there's something subtler at play. Sometimes silence isn't dictated from above, it emerges, like a feedback loop. NASA waits for ESA to speak. ESA waits for China. China waits for NASA. Each agency interprets the other's restraint as caution and mirrors it. Soon, the collective stillness feeds itself, until no one dares to be the first to break formation. It's a kind of diplomatic inertia, and it spreads faster than rumor. Yet, history offers few parallels. When Oumuamua appeared in 2017, the reaction was instant. Telescopes worldwide pivoted in unison. Preprints flooded Arxiv within days. When 2I Borisov followed in 2019, the pattern repeated. Open collaboration, shared telemetry, excitement. Why then did 3I Atlas inspire secrecy instead of spectacle? Perhaps because the stakes have changed. In 2017, the idea of an interstellar visitor was novel, even thrilling. By 2025, the novelty had curdled into unease. Two such visitors in less than a decade shattered statistical expectations. If the third carried anomalies in brightness, trajectory, or structure, it would demand explanations that no agency was ready to give. And so, a new strategy formed: manage the narrative by managing the noise. Internally, agencies may have held meetings, reviewed telemetry, debated interpretations. But outwardly, they spoke in unison, a chorus of caution. Natural origin, ongoing analysis, premature to draw conclusions. These phrases repeated like code, smoothing chaos into comfort. Behind that calm facade, however, small leaks hinted otherwise. An internal memo from a European data archive referenced temporary embargo pending cross-agency alignment. A research request to NASA's Planetary Defense Coordination Office was denied for coordination reasons. And a junior astronomer in Japan posted, then deleted, a message reading, "The data exists. We just can't talk about it yet." The post lasted 12 minutes. The internet never forgets, but institutions do. The next morning, the account was inactive. Whether these fragments represent error, exaggeration, or truth hardly matters. The pattern holds. Silence is not absence, it's behavior. It communicates priorities, alliances, and fears. Across cultures and languages, the message was the same. Wait. But wait for what? For verification? For instruction? For the world to stop asking? Perhaps for something subtler, for the noise to decay until no one's listening. because silence, like radiation, weakens over time. Eventually, public attention drifts, headlines fade, and the truth, whatever it is, can re-emerge safely, rephrased, unthreatening. When silence becomes strategy, it ceases to be passive. It becomes a weapon, one that controls perception without uttering a word. The question is no longer whether agencies are hiding something, it's why they all seem to be hiding the same thing. If you've ever wondered what silence looks like from the inside of NASA, it's not dark rooms and locked doors, it's meetings, endless, cautious, data-driven meetings. When an anomaly surfaces, whether a blurred image, an unverified trajectory, or a signal outside expectations, NASA doesn't panic. It categorizes. There's a word for this: containment, not of the object, but of information. The process begins quietly. An internal flag is raised in the Science Data Coordination Network. Teams across the Jet Propulsion Laboratory, Goddard and Langley, receive identical alerts marked anomalous event, pending validation. That phrase is key. It freezes communication until multiple cross-checks confirm the anomaly is real. In the case of 3I ATLS, those alerts went out in mid-September 2025. Within days, the internal review pipeline activated. Each division handled a fragment of the puzzle: orbital dynamics at JPL, optical calibration at Hubble's archive, infrared spectral modeling under the JWST Science Operations Center. Normally, such compartmentalization ensures reliability. No single mistake spreads unchecked. But in this case, the segmentation itself created a fog. No one person saw the full picture. By late September, NASA had collected enough data to know two things. 1. 3I ATLS was on a hyperbolic trajectory, meaning it was not gravitationally bound to our Sun. 2. Its luminosity curve did not match known models for icy comets at that distance. That alone wasn't alarming. Anomalies happen. What triggered unease was the stability of those anomalies. They didn't fluctuate or decay as expected. The brightness held steady, as if the object refused to obey thermodynamic norms. To scientists, that's not evidence of anything artificial. It's worse. It's uncertainty that won't resolve. A briefing was prepared for senior administration. A decision had to be made: publish early and risk confusion, or hold data until the anomalies could be modeled. The consensus, unanimous, was delay. Delays at NASA are procedural shields. Every hour they wait, every line they verify, every peer review they extend, adds legitimacy to whatever comes next. It's not deception, it's self-defense. The agency learned this the hard way, from decades of premature announcements that turned to dust. In 2010, a supposed microbe that could live on arsenic made headlines, only to be debunked within weeks. In 1996, the Martian meteorite life claim fractured NASA's credibility for years. The lesson: better to say nothing than to retract. But this time, silence lasted longer than usual. By early October, Avi Loeb's independent team at Harvard released a public statement suggesting that 3I ATLS might display non-gravitational acceleration inconsistent with ordinary sublimation. NASA's response? A single sentence: no confirmed deviation from expected natural parameters has been observed. That phrasing, sterile, symmetrical, precise, is NASA's linguistic armor. It means we're not ready to discuss what we don't understand. Inside the agency, scientists debated terminology. Should they call it a comet, a visitor, or simply an object? Words matter because they shape interpretation. Comet implies behavior. Object implies ignorance. The compromise was a sterile hybrid: interstellar body 3I ATLS. Still, something didn't fit. Data from the Hubble Space Telescope captured a faint dust envelope, spherical, not elongated, inconsistent with the solar wind's direction. And when analysts attempted to model the motion of particles, the results failed to converge. The equations balanced, but the object didn't behave. Even within NASA, scientists whispered, Why does a comet not act like one? In the internal logs, a few bold voices urged release. Ambiguity is part of science, one wrote. We should not fear the public's curiosity. But leadership resisted, not out of malice, out of institutional instinct. Transparency is easy when data fits expectation. It's dangerous when it doesn't. And so the reports stayed classified as provisional. The silence stretched on, but within that silence, something subtle shifted. The more NASA withheld, the more meaning people projected onto the void. Each missing update became its own signal. Each absent explanation felt like confirmation of something unspoken. Silence turned from shield to magnet, pulling speculation from every corner of the internet, from conspiracy boards to academic circles. NASA has always balanced two obligations: truth and trust. The first demands evidence, the second demands confidence. But sometimes, truth and trust collide. If you reveal too soon, you risk error. If you delay too long, you breed suspicion. And between those two poles, the agency hovered, suspended, like the object itself, in uncertain orbit. Maybe the silence wasn't about hiding the extraordinary. Maybe it was about protecting the ordinary from collapsing under the weight of its own doubt. In the vast machinery of space science, silence is not emptiness. It's the sound of institutions holding their breath. Silence spreads differently across continents. In politics, it's strategy. In science, it's infection. When NASA went quiet, the rest of the world followed. Not through conspiracy, but through reflection. Like light off glass, each agency mirrored the caution of the other, until the entire planet seemed to stare at the same unspoken question and look away at once. In Beijing, the National Space Administration issued no official statement, yet internal satellite schedules leaked weeks later showing multiple retargeted observation windows. Instruments quietly turned toward Mars orbit, then redirected again, as if someone had looked, seen, and chosen to unsee. The European Space Agency, having released its one ambiguous image, went dormant. No further exposures, no follow-ups. Not even a clarification when questions poured in from press and researchers alike. A few journalists noted how ESA's public servers showed a temporary data synchronization issue that conveniently coincided with the period when 3I ATLS was brightest. The United Arab Emirates, with its Hope orbiter floating above Mars since 2021, maintained a polished silence. Its media office spoke of technical maintenance. Astronomers in Dubai later hinted that Hope's instruments weren't designed for deep space tracking, but their tone carried something else: weariness, as if they'd been told not to ask. India's ISRO, normally eager to publish, quietly shifted focus to its lunar programs. No denial, no curiosity, just redirection. Even Russia, a nation never shy about claiming discoveries, kept its telescopes fixed inward. On the moon, on satellites, anywhere but the faint visitor slipping past Mars. If coincidence explains one silence, what explains 5? Global coordination among rival nations is rare, especially in matters of scientific prestige. To be the first to publish on an interstellar object would mean headlines, grants, recognition, and yet no one stepped forward. It was as though the world had reached an unspoken truce. Better to say nothing than to say too much. Some theorists suggested a simple mechanism, a temporary embargo, perhaps initiated through the International Astronomical Union, meant to synchronize results. Embargoes are common when data overlap. They prevent confusion, ensure uniform publication standards. But those embargoes usually last days, not months, and they end with press releases, not absence. Others whispered about more subtle motives. After the UAP disclosures of the early 2020s, when leaked military footage forced governments to admit they'd seen objects they couldn't explain, agencies had grown hypersensitive. The phrase unidentified had become a political liability. No one wanted to repeat that cycle with something visible from orbit, and so they retreated into caution disguised as consensus. Meanwhile, independent observatories noticed peculiar gaps. Data streams from several large telescopes, VLT in Chile, Keck in Hawaii, Subaru in Japan, all showed uncharacteristic calibration delays in early October. Public logs didn't show the gaps, but internal backups did. For roughly 36 hours, several instruments registered continuous tracking of an object moving too fast for standard cometary motion. Then the dataset stopped mid-sequence, truncated at identical timestamps. To most observers, that meant little. To those who analyze metadata, it meant coordination. In one sense, this was rational. Science values verification, not velocity. Announce too soon, and error becomes spectacle. But the global stillness hinted at something deeper, an emotional symmetry. It wasn't fear of aliens. It was fear of being first. The first to misinterpret. The first to declare something extraordinary that turns out ordinary. The first to stand before cameras and say, "We don't know." And so, the institutions of Earth performed the oldest survival mechanism in human history: collective denial. Perhaps, somewhere in that hesitation, there was wisdom. The universe has punished our certainty before. Every age has believed it stood at the center, until data said otherwise. The silence of 2025 might not be conspiracy at all, but humility disguised as restraint. Still, the pattern haunts. The agencies of Earth, separate in flag, united in fear, now orbit the same moral question. When discovery threatens comprehension, is silence the safer truth? The sky doesn't keep secrets, people do. And when the world's most curious species chooses not to look up, maybe the mirror we're seeing isn't the cosmos at all. It's us. Every discovery begins with light. But in the case of 3I Atlas, light wasn't the problem. Access was. While space agencies debated what to release, the most important data never left the private servers that recorded it. The world's eyes on the universe are no longer limited to government telescopes. Today, they belong to an ecosystem, a patchwork of universities, private observatories, corporations, and amateurs. Together, they form an invisible nervous system of the modern sky. When that system went quiet, something vital disappeared. Amateur astronomers, the stubborn backbone of independent discovery, noticed first. They had tracked Borisov, photographed Oumuamua, even contributed to the Gaia early warning system. They knew what a comet's light curve should look like. But 3I Atlas didn't follow the script. Its magnitude fluctuated irregularly, brightening and dimming in patterns that didn't correspond with known rotational dynamics. In some datasets, the brightness seemed quantized, shifting in discrete steps instead of continuous curves. That shouldn't happen in natural photometry. One observer in Spain posted a graph comparing his data with NASA's predicted luminosity. His post lasted 5 hours before vanishing from the archive. The backup snapshot, still circulating on encrypted forums, contained the caption, "Either my telescope is lying, or someone else's data is." It wasn't an accusation, it was a plea. Soon, similar reports emerged. Subtle anomalies in signal consistency, unexplained dips in brightness, inconsistencies between observatories. Nothing definitive, but collectively they hinted at something uncomfortably persistent: patterned noise. Patterned noise is an oxymoron. Noise, by definition, should be random. When it begins to repeat, it becomes signal. Private observatories noticed the same. Las Cumbres, Lowell, Tenerife, and even the Sky Gems network all logged temporary calibration gaps, 20 to 30 minutes of missing frames. The logs didn't show technical faults, they showed manual interruption. If this were coincidence, it would be remarkable for how precisely it aligned across continents. Corporate satellites joined the silence too. SpaceX's Starlink, Planet Labs, OneWeb, all with cameras capable of detecting transient optical events, released nothing. Their telemetry is proprietary. They don't owe the public access. But that opacity, intentional or not, amplified the vacuum. For the first time in history, the democratization of observation became the privatization of mystery. and yet a few fragments slipped through. In a forgotten GitHub repository belonging to an open-source satellite project, a low-resolution frame appeared, time-stamped October 4th, the night 3I ATLS crossed Mars's orbital plane. The image showed two faint points, not one. The second was dimmer, offset by a few arc-seconds, following a near-parallel trajectory. Could it be sensor noise? A hot pixel? A reflection artifact? Possibly. But to those who've spent their lives staring into darkness, double echoes like that are unsettling. Some theorists suggested fragmentation, a secondary piece trailing the main body. Others whispered of something more deliberate. Formation flying, no one knows. The image disappeared within days. The repository was wiped, its logs overwritten by storage optimization. But the checksum, a digital fingerprint, survived long enough to confirm the file once existed. You might think data can't vanish in the age of backups and cloud archives, but deletion is easy when doubt is the reason. It's not censorship when you delete your own uncertainty. Across thousands of laptops, in countless observatories, small snippets of light, raw photometry, metadata, error codes might still hide in forgotten directories, never uploaded, never processed. Each fragment a single pixel in a picture no one has yet assembled. That's the paradox of our age. The more data we collect, the less truth we can see. The noise grows faster than the meaning. Science is not built to chase ghosts. Funding prefers certainty, instruments prefer calibration, and the public prefers answers that fit headlines. When something like 3I ATLS defies all three, it falls into a kind of informational twilight. Too strange for publication, too subtle for denial. But twilight has always been where the most interesting things hide. Maybe the real evidence was never in the official archives at all. Maybe it lives in those scattered local drives, in the faint heartbeat of deleted files, in the hum of data centers whose sensors once caught a flicker too brief to name. And if 3I ATLS truly was something extraordinary, then the proof might already exist, buried not by secrecy, but by the ordinary indifference of time. Because sometimes the universe doesn't need to erase the truth. It only needs us to forget where we saved it. An anomaly in science is not a scandal, it's an invitation. But when enough anomalies echo across different instruments, something deeper stirs. Doubt in the model itself. From late September to mid-October 2025, data on 3I ATLS trickled through global networks of observatories, both public and private. Every line of that data whispered a contradiction. Orbit specialists at the Minor Planet Center noticed tiny inconsistencies in the object's predicted path. It wasn't drifting wildly, just off by fractions of a degree, but those fractions accumulated, bending the expected trajectory ever so slightly away from simulation. The usual explanation for such deviations is outgassing, the subtle push of gas jets venting from a comet's sunlit side like microscopic thrusters. But there was a problem. No telescope detected any jets, no coma, no sublimation trails, nothing. That contradiction divided astronomers into two camps. The first insisted it was a measurement artifact. Different telescopes, different wavelengths, different error margins. Combine them, and noise masquerades as mystery. The second group, smaller, quieter, believed the data was real. Their reasoning was simple. Error never repeats so precisely across independent systems. When observatories in Chile, Japan, and Arizona all report the same residual drift, the odds of coincidence drop to near zero. So, if it wasn't noise, what was it? A paper circulated privately within the Harvard-Smithsonian Center for Astrophysics, co-authored by a handful of anonymous contributors. The document described non-random acceleration with no detectable mass loss, and used a phrase no official report dared to print: controlled motion. Of course, controlled doesn't mean intelligent. It could mean rotational torque, density asymmetry, or magnetic influence. But words like that ignite imaginations, and imagination spreads faster than math. Soon, amateur physicists online began generating models, simulating a hollow body, a mirrored sail, a tumbling reflector. They found that a flat, high-albedo surface could replicate 3I Atlas's brightness curve almost perfectly if its orientation changed slowly over time, as though adjusting itself. Skeptics countered with thermal arguments. A reflective surface would heat unevenly and destabilize, unless, of course, it wasn't reflecting sunlight at all, but something else. That idea was dangerous because it pointed toward agency, the possibility of design. Science rarely rejects possibility outright. It buries it under better hypotheses. In this case, better meant safer. Unknown composition, exotic ice, internal fractures releasing microbursts of trapped gas. The math didn't fit perfectly, but it was comforting. Still, the whispers grew. Spectroscopy from the James Webb Space Telescope hinted at an unusually high CO2 to H2O ratio, nearly 8:1, far beyond typical comet chemistry. That ratio could imply formation in an extremely cold interstellar region, or a surface material designed to mimic reflectivity while concealing its inner spectrum. One researcher privately compared the spectral pattern to powdered carbon fiber under frost. It was an absurd analogy, poetic more than scientific, but the image stuck. A carbon fiber ghost gliding through space, disguised as a comet. No one published those findings formally. Instead, they surfaced on internal message boards, coded, abbreviated, stripped of context. Stable brightness curve. No volatile signature. Non-linear drift. Unresolved structure. Each fragment on its own meant little. Together they formed a pattern. It wasn't proof of intelligence. It was proof of something that didn't fit. The philosophical tension grew heavier than the data itself. If nature could produce such precision, what else had we misread? If it couldn't, then something, or someone, had sent a message written in the universal language of motion. But scientists are trained to resist narratives, so they reclassified, remeasured, and redacted until the anomaly folded back into acceptable mystery. And yet in private, some admitted what they could not publish, that the odds of 3 consecutive interstellar visitors, Oumuamua, Borisov, and now Atlas, all arriving within a decade, all showing some deviation from norm, were astronomically low. Coincidence becomes conviction when probability collapses. Perhaps, they reasoned, it wasn't the object that was strange, but us. Maybe our instruments, sharpened by bias, were detecting meaning where none existed. Maybe silence was mercy, the universe sparing us from conclusions we aren't ready to make. But then again, data does not lie. It simply waits to be interpreted. And sometimes, what we call noise is just the first whisper of a truth too large to hear. Silence is not absence. It's a form of behavior. And when an object travels through our solar system without speaking, no radiation, no radio, no thermal pulse, scientists begin to build theories to explain its restraint. Theory 1. The frozen artifact. Perhaps 3I Atlas is nothing more than a relic of some dead system, a cosmic fossil, a body of compressed ices and carbon that lost all volatility eons ago. Its surface might be coated in complex organics, pitch-black tar hardened by cosmic rays, absorbing heat instead of reflecting it. Such an object would show no tail, no coma, and no warmth. In other words, a ghost. The frozen artifact hypothesis comforts traditionalists. It demands no alien hand, only time and entropy. In a galaxy this old, lifeless precision is expected. Nature can produce perfection given enough years. Theory 2. The cloaked comet. A more radical camp suggests that 3I Atlas might be surrounded by a dust shroud, not natural, but engineered. A dense, evenly distributed veil of micron-sized particles could scatter light uniformly, masking shape and texture. To our instruments, it would appear as pure noise. To whoever built it, if anyone did, it would be the perfect camouflage. That idea sounds cinematic, yet physics allows it. A thin dust shell could regulate heat, stabilize trajectory, even harvest energy through differential radiation pressure. It would explain the object's faint, consistent brightness and its refusal to outgas despite solar proximity. Still, to propose engineering is to invite exile in science. So researchers speak cautiously, hiding intent behind metaphors. They say high albedo anomalies, non-differential emission profiles, reflective equilibrium, words that sound safe, even when they mean dangerous things. Theory 3, the silent messenger. This one is whispered, not written. It suggests that 3I Atlas is no relic at all, but a probe built for quiet, an observer, not a visitor. If you wanted to study civilizations without interference, you'd send something that emits nothing, reflects everything, and travels just fast enough to appear uncatchable. You'd give it a surface that mimics a comet's photometric signature, so that curiosity looks away. The silence, then, would not be a flaw, it would be a feature. Some scientists dare to run the numbers. At its current speed, 3I Atlas will leave the solar system by mid-2026, bound for interstellar space. Its path grazes the ecliptic at a shallow inclination, passing near the orbits of Mars and Jupiter, an angle statistically improbable for random entry. It's not a collision course, but it's deliberate enough to feel chosen. Could natural celestial mechanics produce such a trajectory? Yes. Could intelligence? Also yes. The equations cannot tell the difference. Theory 4, the quantum drift. A less romantic but equally perplexing idea. 3I Atlas might not be a single body at all, but a swarm of coherently bound fragments, loosely gravitational, behaving as one. In this scenario, the object's stillness is a quantum-scale illusion, hundreds of small reflective particles oscillating together, each masking the other's signal. To optical instruments, the result is stability. To physics, it's chaos disguised as order. That would make 3I Atlas less a traveler and more a process, a natural computation unfolding in space. It's poetic, but unsettling, because it implies the universe itself can imitate design. Theory 5, the human filter. Perhaps the silence does not belong to the comet at all. Perhaps it belongs to us. If our algorithms are tuned to recognize only certain forms of signal, tail, flare, coma, emission, then anything outside those categories vanishes by definition. The data may exist, but the filters erase it before we ever see it. In an age of AI-assisted astronomy, silence can be algorithmic. A computer trained on patterns of known comets might discard something unlike them as noise. A spacecraft's onboard AI could filter readings too low for its detection model. The object doesn't have to hide. Our own tools hide it for us. It would be the ultimate irony, the cosmos whispering in a frequency we ourselves programmed to ignore. Each of these theories carries its own flavor of comfort and terror. The frozen artifact reassures us that we understand nature. The cloaked comet teases us with mystery. The silent messenger tempts us with meaning. The quantum drift dissolves the boundary between life and pattern. And the human filter reminds us that ignorance is often self-inflicted. But beneath them all lies one shared truth. Stillness is data. When an object moves through the heart of a solar system and refuses to speak, the silence itself becomes its language. The question is whether we're smart enough or humble enough to translate it. Perhaps, in the grand scale of cosmic time, silence isn't concealment, it's patience. Maybe 3I Atlas isn't hiding. Maybe it's waiting for us to learn how to listen properly. For all our telescopes and equations, the hardest thing to measure isn't light or gravity, it's ourselves. Every story about the cosmos eventually bends back toward the observer, toward the fragile, curious species staring into the dark and trying to make sense of what it sees. The mystery of 3I Atlas isn't just a question of astrophysics, It's a mirror held up to human perception. When we first discovered Oumuamua, the world celebrated. It was a symbol of possibility, a cosmic postcard from beyond the sun. When 2I Borisov appeared, it confirmed that interstellar wanderers were real, not myth. But by the time 3I Atlas arrived, curiosity had turned into caution. We had learned just enough to be afraid of what we didn't understand. Silence then became our defense mechanism. At institutions, scientists stopped speculating in public. Every theory had a cost. A misplaced word could end a career. A misinterpreted phrase could become a headline. So they spoke only in disclaimers. Preliminary data. Within normal uncertainty. No evidence of artificial origin. The result wasn't reassurance. It was confusion disguised as calm. For the public, silence breeds imagination. For scientists, it breeds paralysis. That's the paradox of human inquiry. We demand answers, but punish uncertainty. We tell science to be bold, then crucify it when it guesses wrong. So, when the sky offers something that defies categories, the safest choice isn't discovery. It's retreat. Psychologists call this cognitive closure, the tendency to prefer incomplete certainty over endless ambiguity. The cosmos, however, offers only ambiguity. It doesn't explain itself. It waits to be decoded. And when our instruments bring back silence, we take it personally, as though the universe owes us conversation. But maybe silence is the conversation. Maybe 3I Atlas isn't a mystery to solve, but a test of how we react to not knowing. Throughout history, moments of collective uncertainty have exposed our deepest insecurities. The wow signal of 1977, a narrowband radio burst that never repeated, still divides scientists. The Mars meteorite controversy of the 1990s made us argue about life itself. The UAP videos of the 2020s forced governments to choose between skepticism and disclosure. Each event began with data. Each ended in distrust. The pattern is always the same. First comes wonder, then debate, then silence, and finally, exhaustion. We turn our gaze away, not because the universe stopped speaking, but because we grew tired of not understanding. It's easy to mock this pattern as weakness, but it reveals something profound. Humanity's relationship with the unknown has never been rational. It's emotional. The unknown feels like a threat because it dissolves identity. If there are things beyond our comprehension, what does that say about our place in the story? The silence of 3I Atlas, then, may not be cosmic at all. It may be psychological, a global nervous system recoiling from its own reflection. When you watch the footage of scientists avoiding comment, of agencies releasing recycled images, of the internet debating ghosts in pixels, what you're really seeing is the human brain defending itself from the infinite. We have built machines that can see farther than our courage can follow. That's why the world's silence feels coordinated, because fear is contagious. Not the cinematic fear of invasion or apocalypse, but the quieter dread of insignificance. The realization that we might be observed, measured, and found primitive. And so, the species that once looked up with wonder now looks down at its own limits. But there's beauty in that vulnerability. It proves that curiosity still matters. Every cautious statement, every hesitant silence, every late-night calculation is still an act of awe. We keep asking, even when we're afraid of the answers. Maybe 3I Atlas didn't come to show us something new about the universe. Maybe it came to remind us how fragile our confidence really is. Because the truest measure of intelligence isn't knowledge, it's how we handle the unknown. And perhaps, just perhaps, the reason the sky went silent is because it's waiting for us to learn the same lesson the universe learned long ago. That silence isn't emptiness, it's patience. There comes a moment in every investigation when the noise fades, the instruments quiet, and all that remains is the faint hum of existence itself. That moment has arrived. By the time you hear these words, 3I Atlas will already be gone, sliding past Jupiter's orbit out toward the heliopause, where the solar wind meets the dark tide of interstellar space. Its trajectory is clear, its destination unknown, like a message cast into an ocean without an address. For months, it haunted us, not through what it did, but through what it refused to do. It never flared, it never sang, it never behaved. It simply passed, indifferent and exact, as though following instructions written in the grammar of gravity itself. And humanity, for all its satellites and equations, stood silent before that indifference. In that silence, something beautiful happened. We began to listen differently. We listened not for the spectacular, the tale, the flash, the revelation, but for the subtle, for the missing photon, the pause between data frames, the quiet shape that lingers at the edge of noise. Because perhaps that's where truth has always lived, not in the light we capture, but in the darkness we ignore. Scientists will go on debating. They will refine the orbital models, publish the residuals, argue over calibration and reflectivity. They will write careful sentences ending in phrases like, within uncertainty limits, and consistent with natural explanation. And they will be right, because that's what science does. It protects its integrity through doubt. But beneath the language of precision, something more human remains. Awe. Awe that our small blue planet even noticed. Awe that our instruments, built by fragile hands, could catch the ghost of something born between the stars. Awe that in the middle of infinite silence, the universe allowed us one brief conversation, a conversation measured not in words, but in wonder. Maybe that's the lesson 3I Atlas leaves behind. Not a revelation, not a warning, but a mirror. It showed us the limits of certainty, and in doing so, it reminded us that knowledge without humility becomes blindness. For centuries, we've assumed the cosmos is waiting to tell us something. But what if it's the other way around? What if we are the ones being tested to see whether a species obsessed with noise can learn to hear what silence has been saying all along? In that sense, 3I Atlas was never just an object. It was a pause, a breath in the symphony of creation. And within that pause lies the most difficult truth of all. The universe does not owe us meaning. We must bring our own. As it drifts now into interstellar night, carrying whatever secrets it holds, it leaves behind no trail, no signal, no trace of purpose, only the question it carved into our collective consciousness. When the universe finally speaks, will we recognize the sound? Maybe the answer will come not through radio waves or telescopes, but through something quieter. The stillness between our own thoughts, the humility of not knowing, the courage to keep asking anyway. Because the universe has always been talking. We just needed to stop shouting long enough to listen. So tonight, look up. The silence you hear isn't empty. It's the sound of creation still unfolding. And somewhere beyond the reach of our instruments, a faint traveler named 3I Atlas continues on, carrying our questions into the endless dark, to places where even silence has meaning.